All right, let's continue. We are now on page 3, and here's where we're getting into our learning objective that has to do with calculating the amount of energy entering or leaving the system. And so here we're going to be doing a bunch of math. Remember, one of the first things we need to do each time is figure out what exactly is going on and how exactly then do we set it up. So question number 13 says, how much energy does it take to melt 140 grams of ice starting at 0 degrees Celsius? So first thing we need to figure out is what exactly is going on. Well, we've got some ice at 0 degrees Celsius and it's melting. So we're going to need a warming curve. And we're going to draw all 5 segments. Even though we're not going to use all 5, we're going to draw all 5 segments. Now in this situation, it says that the ice is melting. That's all that's happening, is just the ice is melting. So we need to know the heat of fusion. Now the question then says how much energy. Since we're looking for energy, we need to find Q. And so our energy is going to be mass times the heat of fusion. Our mass is given to us as 140 grams. We'll go ahead and write that over 1. Our heat of fusion is 334 joules for every 1 gram. And when we do the math, first of all, you'll notice what we have here. Our grams cancels grams. Always make sure that you are showing all of your work, all of your units. By the way, I set up the formula first, then I showed the work with the units in it, and finally we do the answer, 46,760 joules. So again, we want to make sure that we label our answer completely. Question 14 says a 388 gram sample of liquid water at 33 degrees Celsius is cooled to 0 degrees Celsius. How much energy is released? Well, it tells us that energy is released, so we know we're going to have a cooling curve. So we can go ahead and start by drawing our cooling curve. Now it says that the liquid water is cooled to 0 degrees Celsius. It originally started at 33, cooled down to 0. So we're going to go from here to here, and the question is, how much energy is released? Well, the information that we have indicates that it's only liquid water. So we're going to use the equation Q equals mc delta T for our change in temperature. Our mass here in this case is 388 grams. Since we are dealing only with water, it's 4.18 joules per gram times degree Celsius. Now, remember, this is our heat capacity of liquid water. This is a standard that we've been using, that we got the heat capacity of just liquid water. Next, it says our change in temperature is going from 33 degrees Celsius down to 0 degrees Celsius. Now, when we set this up, we see that we have our units of grams cancels grams, degrees Celsius cancels degrees Celsius. We are left just with joules. And then we can do the math. We should get 53,520.72 joules. That's how much energy is released when you cool the sample down. Now, question 15. What is the final temperature of water? What will the final temperature of water be if a 180 gram sample of water, 60 degrees Celsius, releases 18,400 joules of energy? So again, we are releasing energy. So we know we're going to have a cooling curve. Again, for each one, we want to draw out the 5-step segment, or the 5-segment step. And it says we start off at 60 degrees Celsius. It's releasing energy. What's going to be the final temperature? So in this case, since we are looking for the final temperature, let's see how much our temperature is going to change. So we want to find the change in temperature. Change in temperature is going to be Q divided by M times C, where Q is our energy that's released. In this case, the amount of energy that's released is 19,400 joules. Our mass is 180 grams. And since we are dealing with liquid water, it's only liquid water, that we're going to use the heat capacity of liquid water, 4.18 joules per gram times degrees Celsius. Now, when we do this math, we see that it's going to end up going down by 25.78 degrees Celsius. That's how much, that's our change in temperature. The question isn't how much does the temperature change, the question is what is the final temperature? And to do the final temperature, we need to take our initial temperature, and since we are releasing